I want to revisit the idea of code explosion. You can see here I have a do something method, several of them, and perfect opportunity for a generic method, obviously, because the only thing that varies from these methods that say they're going to do something, but they actually do nothing. Sounds like a lot of people I rely on. Anyway, the only difference between all of them is their type argument. Okay, so I can come down here and say do something, and I'm going to make a do something for every single one of these. So do something, look like that, like that. Looks like the second one is a char, so the best letter in the alphabet is J. Bool, we'll do false. Main class, which is our class that holds main. That's kind of contrived, I know, but new main class, and then string. We'll do hello Dolly. I'm not quite sure why that just came to my mind, but we'll roll with it. Okay. So if I F11 through this, which just steps into all these functions, you can see we go through every single one of these. All right. So to make this generic, it's real simple. I'm going to comment this out instead of deleting it for now because I'm going to refer to it. But let's make a generic version. Say T, and then arg can be a T. That's T, and then as I F11 through all this, notice the red squigglies went away, and as I showed in the previous video, I could be explicit here and state the type argument, but I'm not going to. I'm just going to rely on type inference. Hit F11, and we step into the same function over and over and over again. But I explained in the code bloat video, or code bloat, a little earlier, and let me re-illustrate that here. But basically, when the compiler sees do something here, it essentially somewhat has to copy and paste this method over and over and over again. It instantiates that method for every type argument we give it. So it's actually going to be a 5, and it's actually an int version, and there's going to be a char version, and a boolean version, and a main class version, and a string version, except the compiler does a little bit of optimization for us to try to reduce the amount of copy-paste code explosion that it has to do. And that is in the case of reference types. Now, hopefully you understand the difference between a reference type and a value type. If you do not, check out the playlist. But as a really basic explanation, hopefully good enough for this video, a value type is like primitive types like these char and int and Boolean, but a value type, these things, they go out on the heap, and they take up room over there, and a lot of other details. But for now, I think reference type is a type I reference out on the heap, whereas value type, it is the actual object. It's there, and in this case, it's defined on the stack. Anyway, okay, so strings go on the heap, new main class goes on the heap, but these primitive types, they're temporarily stored actually in the program. In the code explicitly, but I have to essentially, if a type is a reference type, as the case is down here with these two, the compiler can actually reuse the code it generated for a reference type in general. Meaning, I could come down here and say do something with a new object, nothing in there, just a plain old run-of-the-mill object. And all three of these are reference types. The compiler essentially has to generate the code for do something, copy paste, all right. For this reference type, but then it uses that same code for all three of these. And here's the key reason why it can. A reference, meaning a reference out to an object on the heap, a reference, I think generally they're 4 bytes or maybe 8 bytes. It's the same size for every single one of these objects. There's no need to do a different do something for this one versus this one, because the reference that will arg here will be a reference out to this object on the heap. Okay, it's a little like when I pass it in there, I'm kind of saying that. All right, arg is it doesn't matter if it's a new main class or a new object or a new string. Arg is still a single reference. Okay, so the compiler will actually reuse the do something it generated for that. Now that's not the case with the value types I have here, the first three. Okay, because an int is not the same size as a char, which is not the same size as a bool. So for all of these value types, the compiler will copy and paste the code. Now I can actually prove that the compiler does this. Let's hit F10, get this program running. And don't panic, I'm going to actually go down to a little bit of the native level. I'm going to go F10, and let's do Control Alt D, I believe. The disassembly. And I wonder if I can make this a little more friendly. We'll put it over there. Okay, notice. And if you don't know what assembly code is, I strongly recommend getting comfortable with this. Take an assembly programming course or get a book at least on it and mess around. Get comfortable with how a processor actually works. We're going down below the .NET level, and don't let this scare you. I mean, eventually all languages have to get this low. But if you look at this, there's a call instruction here, meaning call. Well, first of all, it's putting 5 on the stack here, or in this register here, and then didn't we do a 5 here? It's trying to pass 5 into the function. And now the function slash method, I use the terms interchangeably. In .NET we should call them methods, but the method is simply an address to where to execute code. And it turns out that the address of that method is right here at this location. This is a hexadecimal address out in memory. Okay, so we call that and we can execute it. I'm going to hit F10, step over it. Alright, now we have the char version here. Notice the address of the instantiated doSomething function is different than the address of the instantiated doSomething that takes an int. Okay, so addresses differ. Alright, F10. Now we do the Boolean version. Notice this address is different from this address, but then notice how close these addresses are. But they're still different addresses, still different instantiations of the doSomething code. doSomething's empty. That's why these are roughly very close to each other. Okay, very cool. Let's step over that. Now we have doSomething new main class. Now it has to do some stuff in here to instantiate our main class. But if you notice here, we have let's see, we have 3 calls. Looking over here, I'm going to scroll over here, just peek around, see if I can figure out what's going on. Call. Let's zoom this out a little bit. Oh no, it's just going to scroll. Okay, notice the call instructions here. All right, call hello Dolly. All right. We're calling this one. Well, look, that's the same call that we had right here. All right, and then if we go down to new object and we look for the call, hey, that's the exact same address we had here. So basically, all 3 of these doSomethings are calling the exact same method because we're just using references. There's no point in creating various versions and sizes of doSomething because it's all just a reference and we can reuse that code. So that's nice. That's a little optimization the compiler does so we don't completely bloat our code any more than we have to. So very nice. Anyway, wanted to show you that little trick. Control Alt D brought this disassembly window up, and I can actually look at the native assembly instructions down what the processor actually executes.